The next type of reaction we're going to talk about is single replacement reactions. Sometimes they're called single displacement reactions. Means the same thing though. This is when one element replaces another one that's in a compound. So you have one element that's by itself, and then you have a compound. The element that's by itself, if it's more reactive, will replace one of the elements in the compound. Now, what gets replaced in the compound depends on what that element by itself is. If the element by itself is a metal, it's going to kick the metal out of the compound. If the element by itself is a non-metal, it's going to kick the non-metal out of the compound. Okay, so there's quite a bit more to this once you really get to looking at it. But the generic form, you have A and BC, and that's going to make AC, so A comes in and kicks out B, and then B will then be by itself. All right, here's an example. So in this example, we have copper solid, and then we have silver nitrate. Copper is a metal, silver is a metal. So copper is going to come in, kick out silver, and then silver is now by itself, and copper is now with the nitrate. Okay, here's just a little analogy. So if you had a CD in your CD player, and then you had an empty CD case, and then you were to swap the CD that was in the CD player and in the empty CD case, this would be a single replacement reaction. You're just replacing one thing that was already combined with another, and then it leaves the thing that was in the compound initially by itself, the one that got replaced. So to look at these, you have to keep in mind if you're dealing with metals or nonmetals or positives or negatives. So Ca is 2 plus, Br is 1 minus, Cl is by itself right now, so it's got a 2 there because it's diatomic, but if it were in a compound, it'd be 1 minus. So this shows us that Br is going to be the one getting replaced by Cl, because you have the negative and the negative. So the negative is going to replace this negative. So you get Ca and Cl, and now Br is by itself. The compound you must do swap and drop with. So 2 plus 1 minus swapped and dropped gives you CaCl2. And then whatever's by itself gets evaluated to see if it's a diatomic element. And it is a diatomic element, one of the special 7 that's always by not by themselves. They always have to have a little buddy there. Okay, and it's already balanced. All right, let's look at another one. All right, in this one we've got magnesium. Magnesium is a metal. When it's in a compound, its charge is 2 plus. H is technically a nonmetal, but in this instance it has a 1 plus charge. And Cl is 1 minus. So the positives are going to be swapping places. So H will be by itself, and Mg is going to be in the middle now. Now the one by itself gets evaluated to see if it's a diatomic, and H is. And then in the compound, you're doing swap and drop. So we got Mg 2 plus Cl 1 minus, we get Mg Cl2. And then to balance the equation, we would just put a 2 there. Okay. All right. Here we have aluminum in a compound. It's 3 plus. Sodium, it's 1 plus in a compound. And then the polyatomic CO3 is 2 minus in a compound. So the positives are going to swap places. Okay, now this is assuming that the most reactive element is out here, okay? So you have these in a compound. The only way carbonate is going to get rid of this sodium is if aluminum is better. I haven't taught you how to do that yet, but when I do, just make sure that you keep reactivity in mind, okay? But the positives would replace each other. So you'd get Al with the CO3, and that 3 comes because it's attached to a polyatomic. It's not from a swap and drop. And then now Na is by itself. By itself gets evaluated for being a diatomic. This one's not. And then over here, we got to do a little swap and drop with charges. So we get Al2 and then CO3 parentheses 3. Okay, then we got to balance this. So we're going to go ahead and put a 3 here. Gives us 6 NAs and then 2 ALs. Okay, all right. Here we have copper. We have a Roman numeral telling us the charge is 1 plus. Ag, charge is 1 plus because there were no parentheses around the polyatomic NO3, which charges 1 minus. All right, so positive's getting kicked out here. So Cu gets NO3. Compounds get swapped and dropped. 1 plus, 1 minus cancels. And then you also have the Ag, which now is by itself. Make sure it's not a diatomic. It's not, and you're already balanced. Okay. Oh snap, I'm capturing the screen. I didn't want to do that. Okay. Now Cu, now we got a Roman numeral 2, so that's telling us this is a 2 plus. Ag is still 1 plus. NO3 is 1 minus. Positive still going to get kicked out. Alright, Ag is not a diatomic, so we don't need nothing. And then we got to swap and drop our compound. So this gives us Cu NO3 2 from the swap and drop. Man, I keep hitting that button. Apparently, I don't know what button I'm hitting, but I'm hitting a button. Alright, and then we're going to put a 2 there and a 2 there, and that'll get us all balanced. So notice the difference when you have a different charge associated.